first of many webinar training our series in 2022. We're excited to be here. We're going to get things kicked off today shortly, talking about their Instant Underflow Dam. Really, major issue is, when you have containing and cleaning up spills and ditches and inland waterways, that can be a huge challenge. So what we're going to do today is we're going to go over some effective tools to prevent oil spills from spreading if they hit a water source. My name is Mike McKay. I'm the VP of Sales with HalenHardy. I'll be your host for today. Want to go through just a few housekeeping items and then we'll get started. Keep an eye out after the webinar today. You're going to be getting from our production, our training, and our marketing teams have come up with some really effective how-to videos and additional product details. Keep an eye out for that email after the conclusion of the webinar today, and we'll get those tools out to you to add some additional layers onto the presentation we're going to see today. Also, for the questions, looking forward to getting questions from everybody involved today. We got a great audience with us today. We encourage interaction. Please, if you would, keep the questions to the chat. Sarah Noy, who's our client success coordinator, is going to be managing that chat feature. So as we go through the presentation, we're going to have some time carved out at the end to address those questions. So looking forward to that. If we don't get to every question, please still put it in the chat or email clientsuccess@halenhardy.com and we will get back to each question. We have a 60-minute webinar planned for today. With that being said, we do have the ability to go longer than 60 minutes, which we're planning on doing if there's questions that take us longer than that. So feel free to join us there. Also, just wanted to get rolling here and introduce a couple of the presenters. So Troy Beavers, he's one of the partners here at HalenHardy with over 9 years of experience working with environmental experts and operators to really solve complex problems when it comes to spill and sediment control. And we also have a special guest with us today, Bill Dennis from Ardent. He's the principal at Ardent with over 20 years of environmental experience in many facets, which Troy will get into as we start the presentation. So Bill, Troy, great to have you here. Take it away.
Awesome. Thanks, Mike. Yeah, as Mike said, I'm Troy Beaver, partner here with HalenHardy. Before we jump into the main part of the webinar, I just wanted to introduce Bill from Ardent Environmental. He's going to be co-presenting with me today and helping this be more of a dialogue rather than just me talking. We always find it beneficial when doing these to have everyone get a chance to hear the perspective of our clients and be able to ask them questions as well. With that said, I've had the privilege to know Bill for over a decade while working with him as an environmental consultant to the COO of a large Midwest environmental contractor and now as the owner of Ardent. His 20 years experience in the environmental industry is evident every time I get a chance to talk to him as well as work on projects with him. His experience as both a consultant and contractor will definitely help give us a unique perspective today when it comes to the challenges as well as the solutions that he's seen over the years. He's been a valued partner to us at HalenHardy due to our mutual desire to deliver cost-effective solutions that rapidly address environmental hazards and minimize our clients' liabilities. At this time, I'm going to let Bill just give you a bit about Ardent, and then we can hop into the general webinar.
Okay, great. Thanks, Troy. As Troy mentioned, I'm a principal at Ardent Environmental Services. We are a full-service environmental contracting firm performing emergency spill response, scheduled environmental services, and remediation. At Ardent, we're focused every day on obviously delivering for our clients, ensuring their needs are met, their liabilities are protected. And in doing so, we're always looking for better ways of doing things, faster, more efficiently, higher quality. And that's why I'm on the webinar today. In addition to the things that Troy said, I can tell you that HalenHardy is a strategic partner with us because they have better ways of doing things. As Troy mentioned, he and I go back many years. I can tell you that he and his team are a group of integrity-bound, trustworthy, and very clever folks who think the same way that we do at Ardent. So we've aligned ourselves with them because they simply deliver for their clients the same way that Ardent looks to deliver for ours. I can tell you that we use their products exclusively. They're all outstanding. They work great. With respect to the Watergate product that you're going to see today, I've personally deployed them across a number of sites. And like the rest of their products, they work awesome. It's really a brilliant product. And looking at the attendee list, there's a lot of folks on here that I know have deployed them as well. I'm sure that they would be an advocate if they were asked, the same way that I am. If you've not tried one, I think after you see it perform today, you go see it perform live, you'll be an advocate too. So looking forward to it. And Troy, I'm curious to hear about the rest of the dam presentation. Thanks.
Awesome. Thanks, Bill. Appreciate that. Before I jump into the underflow portion of the webinar, I know there may be a lot of folks on here who may not know us at HalenHardy, so I'm just going to do a quick overview of who we are and what it is we do. So our mission at HalenHardy is to help our clients simplify spill and sediment control. We do that by helping environmental and operations professionals by developing products, especially made for the mobile outdoor workforce, ensuring that our products occupy minimal space on your vehicles, equipment, or facilities, as well as designing products to deploy in about half the time and are easier to maintain than conventional options out there on the market. Our 4 core areas that we focus on are spill containment and cleanup in the outdoors, and that's anything from land-based spills in wet, rainy conditions to containing and cleaning up spills on water, which obviously I'll be talking a little bit about today, as well as products for putting under persistent equipment leaks in the outdoors. Second core area is filtering oily sheen from stormwater inside of secondary containment. Third is filtering sheen, silt, and sediment from stormwater runoff, and that's anything from around storm drains to ditches and outfalls and pervious contaminants from escaping site. And then the final area, which I'll touch a little bit on as well today, which ties in nicely with the underflow dams, is our instant coffer dams for dewatering applications. Anytime you're doing stream crossing work where you may be installing something across a stream, you need to dam up the stream quickly. We have a line of products around that dewatering side of things. So quick question before we get in, if you just want to throw it into the chat to kind of give us an idea, how many of you have had the chance to or have built or seen an underflow dam being built? Just throw a thumbs up or maybe a yes or no in the chat. That'll kind of give us an idea here real quick of how many people have actually seen this before I hop in.
Hey, Troy, I've not only built a bunch, but I've seen a bunch fail, not function as designed, have to be modified, have to be redone. So those aspects, I'd be curious as well to see how many people have seen them completely fail and not work as advertised.
Yeah, I'm gonna talk a little bit about that obviously today, but when they work great, but when they fail, they can fail miserably. That's for sure. All right, so now that we've had a chance to kind of ask the question, just going to kind of give you a brief overview of what are traditional underflow dams, how do they work, and maybe some of the difficulties with them. Then I'll hop into the Watergate Instant Underflow Dam and talk a little bit about that product. An underflow dam traditionally is a very effective way to stop a spill from spreading in ditches and shallow streams. The way it works is you dam up the stream typically with dirt or sandbags. Obviously, as water starts to fill up the dam on the upstream side, the floating oils will float to the top. So if you're looking at this picture on the right here, or the illustration, you can see what I'm talking about. The left of that picture would be the upstream side. Obviously, the right side is the downstream side. You then install pipes at an angle so that the end of the pipe on the upstream side sits below the floating oils, and the clean water can continue through the pipes to the downstream side. This allows the water to not continue to build up behind the dam and potentially have the oils flow over top of the dam. So essentially you can contain that spill, especially in shallow streams or ditches. But obviously, as the water builds up on the upstream side, you don't want that contaminant breaching the top. So you have to have a way for the water to continue downstream. So why underflow dams and not some other commonly used methods for containing spills on water? Well, when oil fuel spill reaches a ditch or a shallow stream, common methods for containing the spill, like containment or absorbent booms, can generally become ineffective. Why is that? With containment boom, it is generally ineffective in shallow water where the draft is greater than about 1/3 of the water depth. The restricted flow under the skirt increases the flow, which then increases the oil entrainment. When it comes to absorbent booms, water and oil are going to want to flow the path of least resistance, right? So a lot of times, due to the lack of water depth, booms will get caught up on rocks or other debris in the stream and cause gaps for the spill to easily escape. Underflow dams traditionally address these issues by effectively being able to stop the spill by damming up the stream and stopping the flow. Not to mention, it can help create the depth of water you need on the upstream side. So then you can install something like the containment boom or absorbent booms to become more effective at cleaning up the spill and containing it. With that being said, there are some difficulties associated with traditional underflow dams. They tend to be very material intensive. As you can see here in this picture, a lot of sandbags. A lot of times they're built with earth or dirt. Obviously, you need the pipes to install. Also, a lot of logistics required to get that stuff to site to be able to install it. Very labor intensive. Obviously, you're going to require a lot of manpower or equipment to be able to install something that requires so much earth, sandbags, and other pieces of equipment. It's very difficult also to reach remote areas. The increased equipment and materials makes it or limits the areas where it can be built, right? So if you're over a steep bank in a remote area, you're probably not going to be able to get a piece of equipment or a lot of sandbags down into that. So you may have to wait and go further downstream and install the dam. Increased contamination, obviously, due to the time and labor that it takes to build. Crews must get far enough ahead of the spill or downstream from the spill before the spill reaches them to be able to have enough time to install a traditional underflow dam. In addition, when you're installing the pipes, you got to calculate how much pipe's going to be needed to ensure that you have enough flow going through those pipes so that the spill doesn't breach the top of the dam. So sufficient pipe must be used to handle the maximum stream flow. The number, the size, the length, the positions of the pipes vary with the volume of water, obviously the velocity, as well as the width of the stream. If you have insufficient pipes, it could lead to cresting the dam, and pipes that are too level or allow excessive drainage will allow the oil to actually pass directly through the pipes because the level of the water and oil is staying at the level of the pipes. You're also going to have some difficulties with flow changes. So anytime that you may have, let's say, a heavy rainstorm comes in while you're trying to install an underflow dam, you may need to add more pipes or adjust the dam height. The tough thing with adding more pipes is once they're installed, you really have to remove either some sandbags or earth, which then doesn't give you the height of the dam that you need to properly contain the spill. And then the final area that we've run into over and over again that Bill talked about previously is the failure aspect. One, if the dam's unlined or not wide or compact enough, water could saturate that dam, causing it to fail. And also in the event that you would have some sort of heavy rain event and have this installed, that could easily cause it to wash out and need to be rebuilt.
Yeah, Troy, I've seen a lot of traditional ones built, and ones that we have built, ones that we've not built. And I can tell you, I was thinking about last night. I bet 3/4 of them, of the traditional ones, required some type of substantive modification after the initial installation to get them to work properly. And then a smaller percentage just failed completely, but maybe as high as 20% has been my experience.
Yeah. So that's where the instant underflow dam comes into play. I want to introduce you to the technology and then talk about some deployment methods and different ways to combine solutions to make it the most effective. But the instant underflow dam, it's a lightweight portable solution, can deploy in minutes with 2 to 3 people. It actually just uses the weight of the water as it flows into it to weigh it down to the stream bottom. So there's no anchoring required. It has easily adjustable underflow holes already built into the downstream side. So there's no calculations needed as far as how many pipes you need. And if in the event that flow changes do happen, you can actually just open or close as many underflow holes as you need to regulate the depth on the upstream side, as well as the fact that due to the fact that they can be attached together, you can have unlimited lengths. So how does the underflow dam work? The concept's the same as traditional underflow dams, except you have all the components built into a single solution. So looking at the left side of the picture here, this is the upstream side. As water flows into the dam deploys itself, just using the weight of the water to hold it to the stream bottom. As the water fills the dam, the oil obviously floats to the top. Now you have your depth of water needed to start to do your cleanup efforts on the upstream side. In order to prevent those oils from breaching the top of the dam, there are built-in underflow holes on the downstream side that you can easily open and close to regulate the flow of water. What are some of the components of the system, just to kind of give you an overview, and then we'll get into some videos and some pictures here of actual deployments. Again, the left side is the upstream side. The base fabric is the portion that sits on the stream bottom. The gray partitions in the middle help ensure that if the dam reaches its maximum height filled with water, the retention fabric, which is the top of the dam, doesn't just blow over from the force of the water. On the downstream side, you have the previously mentioned under. There's also an anti-erosion flap that makes sure that when the underflow holes are open, the water flowing out of them is not digging out the stream bottom on the downstream side of the dam. And then finally, you have the heavy-duty lifting straps. These are useful when removing the dam from the stream, but also used to hang the dam up when cleaning and drying it after use. So as I talked about before, no anchoring required. So how can the dam stay in place without any anchoring required? It's actually engineered at a 4-to-1 ratio. So the width from the upstream side to the downstream side is 4 times the retention height of the dam. This means that you get 4 times the vertical thrust compared to the horizontal thrust, which gives it great adherence and not requiring it to be anchored to the stream bottom. So a quick video on how it works. All you need to do is get it centered on the stream or the flow. You want to make sure that on each bank, you're up about a foot or so higher than whatever the height of the dam is. Once you have it positioned, all you're doing is submerging the upstream bib. Have some ballast around, whether it's just rocks from the stream bottom or a few sandbags, just to hold it in place until it gets about 2 to 3 inches of water depth in it. Once it has about 2 or 3 inches of water depth in it, it starts to hold itself in place, and actually that ballasting isn't required anymore. Then you can install absorbent boom on the upstream side. In this case, we have our spill boa, which is 25 foot in length, which is the exact size of this dam. So it easily tucks underneath. It protects the dam from contamination, but also gives a little added flotation under that upstream bib. Obviously, if you watch on the stream bank on the right, you can see this is a time lapse of about 10 minutes as water starts to fill the dam. Now you got to contain, you're creating your depth on the upstream side, which allows you to divert, deflect, and do your cleanup efforts on the upstream side.
Hey, Troy, excuse me real quick. If you wouldn't mind hitting full screen on your computer.
Yes.
Thank you.
I gotta get out of that then. Better. So let me skip back ahead.
Thank you, Troy.
Yep. And then, so as water starts to fill the dam, obviously you don't want the oil to breach the top of the dam. So on the downstream side, of underflow holes built into the downstream side. They easily open and close, as I mentioned before. So now you can regulate the flow of water on the downstream side. And then removals, as simple as going to the opposite bank of wherever you want to swing it to, pull it off the bank, allow the water to start to flow around the outside. It will actually swing to the bank that you want to pull it out at. Once the flow gets back to normal flows, you can then pull it out, wash it up, and reuse it on the next job. So what are some of the different attributes and benefits of it? As I mentioned before, the underflow holes. Here you can see a close-up of the underflow holes and how they work. Again, just heavy-duty Velcro that holds them into place. You can open them. They don't even have to be fully open, so you can actually only half or quarter open them if you don't need that much flow coming through it. But either way, easy to open, easy to close, in order to regulate the flow on the upstream side, preventing the oil from breaching the top, but also making sure that the depth doesn't get too low so that the oil goes through the actual underflow holes. Second key attribute is obviously storage space. As you can see here on the right is a 28-inch high by 25-foot long dam. That's the dam that you actually saw in the first video that I showed you. The equivalent needed to build a similar size dam would be about 550 sandbags. So you can see here, this rolls up into about a 16, 17-inch diameter by about 20-inch tall roll, and can easily be carried by a single person. On the left, I don't think I need to tell you how many people or how much equipment it would take to be able to get 550 sandbags down into a stream to be able to install a traditional underflow dam. In addition, I mentioned before the unlimited lengths. So they easily can be attached together. Standard sizes tend to be 25-foot or 50-foot. Most of the time, folks just get 25-footers because that covers most small streams and ditches. And then in the event that they need longer lengths, then you can obviously attach them together and make longer lengths. So you can see here on the picture on the left, that was approximately 75-foot of dam needed to cover the width of that stream. Quickly access to remote areas, as I mentioned before, or mentioned a few times actually. Obviously, if you got to get into remote areas, the biggest thing is how quickly can you get the spill contained. You don't want to wait until you can get to a point of ease of access if you can get down in there and quickly get the spill contained. So the nice thing about this being lightweight, portable, easily deployed by one or two people, is the fact that you can quickly access remote areas. And I think actually this picture on the left, Bill, you can probably tell a story about that one because I think that was one of your deployments.
Yeah, it was an historical deployment when I was with the company previous to Ardent. This was a Midwestern spill release response. Pole-mounted transformer had leaked some transformer oil. Happened to be on the edge of probably a 30, 35-foot wooded ravine. Of course, the oil went down the ravine, hit a waterway at the bottom of that valley, and was on its way to mobilizing further offsite. Just going back to that last picture where Troy showed, the single individual carrying that rolled up water gate on their shoulder. That gave us the ability to walk down the ravine and very close to the source of the spill, deploy the water gate. In these spill response situations, speed, you all know speed's of the essence, and the faster that you can get things stopped, you have a lot less to clean up, you have a lot less impact, you have a lot less damage to resources and everything else. So it was invaluable to us. We went right down that wooded valley, got the thing deployed near the source of the spill, and had a much smaller area that we could then focus on for the overall cleanup effort.
Yeah, thanks, Bill. And I know, I don't know, I can't see right now who's all in here, obviously we have a lot of people attending, but I think the picture on the right is a picture from Steve Pelna with Lewis as well. So Steve, if you're in here, if you want to raise your hand, maybe at the end here before the question and answer session, maybe you could tell the story if you're willing to. If not, don't even worry about it. I'm not going to put you on the spot, but. The other benefits that we talked that I wanted to talk about today, obviously, is the time saving aspect. With traditional underflow dams, you're looking at whether you need a piece of equipment like a front end loader or whether you're building it with sandbags, plywood, pipe, visqueen, those various aspects. You're looking at from the mob time to the deploy time to the tear down time, approximately on the low end 6 hours to do all this. And this is a comparison of a 28-inch high by 25-foot long dam. Obviously, time's going to shift depending on width of stream, depth of water, height of dam that you need. But I'm comparing both of these to our most commonly sold underflow dam, which is the 28-inch high by 25-foot. So traditional underflow dams, you're looking at a minimum of about 6 hours between mob, deploy time, and tear down time. With the instant underflow dam, same size, 28-inch high by 25-foot long, you're looking at under an hour. And I think that's being generous, with most of that being in the mob time. The mob time obviously can go down significantly because the fact is you can keep these things stored on site. If you do have facilities where you have potential for releases and they can be close to the stream and grab them. So that mob time can even go down significantly more, not to mention that you can store. So if you're responding typically with a spill trailer, this can be stored easily on a pickup truck. So instead of having to go to the shop to grab your spill trailer, you can actually the first person on site can show up with one of these, also reducing the mob time. Obviously, no trailer or flatbed required to haul anything like equipment or sandbags. No time required to calculate the flows. Obviously, minutes to deploy and tear down, as well as easily take out and reinstall in the event that you would have a heavy rain event and you need to tear it out just due to the fact that it's like a flash flood scenario. Not only on the time aspect, from a money aspect, if you look here on the left, again, comparing the same things, 28-inch high by 25-foot long, you talk about the equipment needed, the sandbags of plywood, the pipe, the visqueen. The majority of this, as I mentioned before, comes in labor. So a lot of the labor costs, right, are in the mob, the tear down, the building of the underflow dam. Not to mention, you have an additional cost of disposal fees after the fact because all this stuff is not reusable. So it's going to have to go to some sort of landfill. And I think, Bill, you can probably talk to that side a little bit more than I can. Am I good on those numbers?
Yeah, probably a little bit low in today's world, but yeah, they're reasonable and correct order of magnitude.
Yeah, and then as far as the instant underflow dam goes, I mean, really, you look at the comparison between labor costs, significantly less labor costs. The dam itself runs right around $2,900. The nice thing about this is you also don't have any disposal costs associated with the instant underflow dam. So it can be washed, reused multiple times. We've had contractors that have had them upwards of 6 years, used them on dozens of spills and still using the same dam. So on top of that, you have, no transportation costs, limited manpower costs, as well as no equipment costs associated with the instant underflow dam.
Yeah, couple things, Troy. Just, it's obvious, but I want to say it. Traditional underflow dam's an ephemeral thing. It goes away once you're done with it. You have no asset to use after the fact. Obviously, if you're buying a water gate, you have that asset that you can use multiple times. And we've had some, like Troy said, for 5-6 years with no issues in their performance whatsoever. I'll also say that in every single case, everyone that we have purchased over the years, they paid for themselves the very first time that we used them. And for whatever reason, it always happened that every time we would buy one, we would end up getting a spill where it was to be used within 10 days of the purchase. So I don't know if it's just magic, but it always happened that way. And the economics work out that they pay for themselves immediately and multiple times over.
So not really switching gears here, but moving on to what about the instant dams for non-floating oils? We get asked this question a lot. Obviously, the underflow portion of the dam is great whenever you have floating oils or fuels, but a lot of times or frequently you may run into the situation where you have sinking oils or non-floating oils. So the solution for that is number one, obviously you can keep the underflows closed. We also have a version without any underflow holes for that scenario. I'm going to work the same way as the underflow dam as far as deployment goes. All you're doing is allowing the water, the flow of the water to fill the dam. It's going to hold itself into place. The nice thing about these dams is they can be overtopped by 33% of the height of the dam, which allows 33% of the water to continue to flow over the top. We also have what we call our diverter attachment. The diverter attachment just attaches directly to the top of the dam. It'll actually flow about 1,440 gallons a minute through it. So in the event that you would have some sort of non-floating oil, sinking oil scenario, and you need more of an overflow dam as opposed to an underflow dam, this can also be a solution for you. Again, about 1,440 gallons can flow through it. So now you can divert that to downstream while keeping the floating oils or sinking oils contained on the upstream side. I wanted to talk a little bit too about combining solutions. Obviously, as we talked about before, in ditches and shallow streams, one of the difficulties with traditional containment or absorbent boom is the fact that there's not enough depth of water to be able to properly install them a lot of times. So the one thing that the underflow dam can do is create that depth. So now, not only are you creating slowing the flow of the water, which makes for easier install of your containment boom on the upstream side. Here, I'm actually showing the HARBO rapid boom, which is a 50-foot. I'll show you this in a second as another rapidly deploying tool that a lot of our customers use. But either way, what you can see here is the fact on the downstream side, you can install your underflow dam, slow the flow, create the depth. Now you can install your boom on the upstream side, which allows you to divert to an easy place to collect whatever the product is that you spilled. Also, some things to think about whenever you are installing this. Obviously, as you do create more depth on the upstream side, there is potential for more bank contamination on the upstream side, as obviously water rises in depth, the floating oils continue to rise. So you do have the potential to contaminate more banks on the upstream side. So here was actually a spill at one of our customers that was sent to us. You can see obviously the underflow dam on the downstream side there contained. You got your absorbents right around the dam to start collecting and cleaning up the spill. But if you notice on the left side of the picture, the ability to really protect the banks, we have our sheen fence filter fence there protecting the stream bank, and then our Spiltration Husky absorbents on the far left there, which really just layer the bank and protect it from contamination in the event that you have a higher flow event happening and the contamination can breach the fence on the left side there. Other applications, as I mentioned before, we also do the cofferdam version. We call it the Instant Cofferdam. This is for stream crossing projects. So you can quickly dam up a stream in a matter of minutes, whether you're doing a diverter attachment and doing your work by using that on the downstream side, or whether you're doing some sort of pump around dewatering application. Just another application that you can use the instant dams for. These actually go up in height all the way to 60-inch high. So we've done projects as large as I just did one that was 180 feet width stream, 60-inch high dam. We had it all completely installed within an hour and a half. So. Some other rapidly deploying solutions that I mentioned before, not to mention the underflow dam. I did talk about the HARBO, and I'll get into that in a second. You saw in the very first video that I showed what we call our spill boa absorbent barrier. same concept, which is takes up less space, about 80% less space than your traditional boom, as well as deploys about 10 times faster. So if you notice in the picture on the right there, that's about 330 net feet of traditional boom on the right side of that picture. On the left side is the same 330 net feet of our spill boa absorbent. Rolls up really tightly, deploys just like a fire hose, and has a high absorbency to it. Finally, the other rapidly deploying solution that I already mentioned is the HARBO first response containment boom. This is actually, if you look at the canister on the left, think of it about the size of a large suitcase. In that is 50 feet of containment boom, 12-inch containment boom, 4-inch float, 8-inch skirt. Again, can easily, just like the underflow dam, be deployed by 1 or 2 people in a matter of minutes. Can be stored easily at remote sites or easily access remote sites, so you don't need an entire boom trailer to get it there. So these are just a few of the other solutions that typically we combine with our clients when thinking about ways to rapidly and quickly respond to spills that may have reached a ditch, a small stream, or an inland water source. So I wanted to leave a decent amount of time to have questions. So hopefully we can get some of those answered. And obviously, if there is anyone that wants to raise their hand and say something, feel free, and we'll throw you on volume. So why don't we start there? If anyone that's used the product, go ahead and hop in. And then if you guys want to throw your questions into the chat, we can kind of start rattling off some answers to those. So I'll start with, so first question, let's see here, is there a maximum water speed that it can be deployed in? Typically what we like to say is it safe to work in that? Typically, if it's not safe to get in there, because obviously you're going to need people in the stream to deploy it, then you're probably not going to be in the stream deploying the underflow dam. With that said, it's not going to affect the efficacy of the dam, because as soon as it's installed, it instantly slows the flow of the water. So it's going to hold itself in place and instantly slow the flow. So then you don't have that water speed issue anymore. So no, it's not going to affect the efficacy as far as flows go. The biggest thing that I always mention to our customers is the fact that you just want to make sure that it's safe for your workers to be in. So if it's not safe, then it's probably not a good idea to be standing in the stream deploying it.
Next question, how readily can they be decontaminated, if at all?
Yeah, so the biggest thing that we find, and Bill can talk to this too, typically just power wash off after the fact. Obviously, you want to do as best as you can to protect the contamination from reaching the dam. But even if it does, just as you would decontaminate, a containment boom or something similar to that, it can easily just be power washed off. The biggest thing is the Velcro on the underflow holes, as well as the Velcro on each end where you would attach multiple units together. Just getting those power washed out as best as possible to prevent, or enable them to be able to work properly in the future. As far as washing out, just get most of the debris out of it by power washing again and making sure that you have it completely dry before you roll it up and store it, because that's going to be what can create some mold. But either way, even if you don't mind the smell of mold, it's not going to affect the efficacy of the dam.
This gentleman said, we have a lot of heavily eroded cut banks around here. The bank in the one picture looks steep, but how high can you go and have it stay in place?
Yeah, so you can actually have it go as high as you want. So we've had situations where, let's say you have a ditch that's only 3 foot wide, but you have a a super steep bank and a 25-foot long dam. You can actually have that excess of dam go completely up the bank and even up to the flat part and just run out onto the flat part of the bank, because all it really needs is the portion that's in the stream within the bank's limits to work. So all the rest of that is just excess that will actually sit up there, but not affect the efficacy of the dam.
We have another, more of a statement here, but maybe you can say something to it. It says, I've been involved in stream bank native plant installation plantings. It looks like the cofferdam would be handy to draw down the water to make planting in muddy banks less disruptive and to make access a lot easier for planting technicians.
I think that's an accurate statement. You're gonna be able to quickly dam it up. Obviously, some sort of either pump around application or diversion through the diverter to continue to allow the water downstream. But yeah, you can take it down. Obviously, most streams are going to have a permeable bottom to them, so you're always going to have, you know, a little bit of water trickling underneath. But yeah, you can significantly drop the depth on the downstream side to do those types of things. That's correct.
Are the dams modular so they can be connected together?
Yep. So heavy duty Velcro on each side. So you can attach multiple units together. As I mentioned, we've done upwards of the largest project that I've done is upwards of 180 feet of dam attached together. Yeah, so that's anywhere from, depending on if we use 50 or 30-foot versions, you know, anywhere from four to six dams attached together at a time.
This person said, wondering if or how the dam performs in harbors, ocean banks, and does anyone have a feel for the release volume for which it makes sense to use rather than traditional absorbent booms or mats?
I guess I'm kind of confused on that question. Could you repeat that? Sorry, Sarah.
That's okay. It says, if or how the dam performs in harbors and ocean banks, and does anybody have a feel for the release volume for which it makes sense to use rather than traditional absorbent booms or mats?
It's a good question. I'm actually going to have to think about that one a little bit more. I apologize if I can't answer that one on the spot. To answer the question, I haven't seen a lot used in ocean harbor applications per se. You know, most of this is a flowing stream replacement for traditional overflow or underflow dam scenarios. But I don't see why, if you do have some sort of harbor where you're getting some flow coming in from an ocean or a water source where it couldn't be installed. The biggest thing is it does need some sort of flow to hold itself in place. Obviously, if it's more of a stagnant water application, you're actually going to have to anchor in that scenario because you're not actually getting any flow coming into it. So you're going to have to anchor it into place in order for it to stay in place until it starts to fill up.
Okay, it says, have you ever seen entrainment of oil in the water at the outlet if flows are higher?
So at the underflow holes, I'm assuming is the question. We've never seen any entrainment. So typically what people do, if it's a low flow scenario, you keep the underflow holes, they may be closed the entire time, right? Because the flow's not enough. It's just building the depth. And by the time you have the spill cleaned up, you may never even need to open the underflow holes. So on that outlet side, you may get some entrainment. The question may be, for this one was for the cofferdam with the diverter attachment. Obviously, yes, in the event that you would have a flash flood or higher flow events that may raise the water level to the level of the top of the dam, you may get some entrainment that's going through the diverter attachment or over the top of the dam in the event that you have a sinking oil. But for the most part, it should prevent the majority of that stuff from overtopping the dam.
Is the dam material impervious to harsher chemicals like corrosives?
Yes, I can get whoever asked that question. We can get you. Actually, we'll be able to send out to everyone the user guide. It has the list of all the chemicals and its resistance to them. So yes, to answer your question, I don't have all of them off the top of my head, but yes.
What is the desired length across the waterway? Meaning, could a waterway be too wide to diminish the efficacy?
A waterway is not going to be too wide. The biggest thing that you need to remember is you have enough dam to make sure that you're above the height of the dam on each bank. So where it could become ineffective or not having enough dam is, let's say, if you have a steep bank, it's pretty easy to quickly get up to above the height of the dam, right? Because let's say you have a 28-inch high dam and the bank is completely almost a 90-degree angle. You're only going to use up about 3 foot of dam to get above that 28-inch height on each bank. But let's say you have a really low sloping bank that's not that steep. So in order to get it above the height of the dam, you may need to run it out 10 or 15 feet on that bank in order to get above the height of the dam because you don't have as much slope on that bank. So to answer your question, the width of the stream isn't going to affect the efficacy. But what could happen is you may not have enough dam because of bank height issues. So it's really just knowing that before you go in to deploy and making sure that you have enough dam for the scenario that you're running into.
Would you suggest workers wearing personal flotation devices?
It's never a bad idea. Most people do. I apologize for the videos with me not wearing one.
And that looks like that's the end of the questions.
I think I saw some hand raises, maybe.
Got one, I think it's Rex Miller. Let me see here.
And Ty.
We do have another question just came in. It says, I do not have firsthand knowledge, but a coworker deployed the water gate on a creek during a spill, and the next day they found that part of one of the sides of the water gate had washed out. My question is, could you attach line to the D-rings and make that line tie off to a tree or a fence post to ensure water gate would not be washed out?
So the problem with Watergate washing out would be the scenario. So you saw whenever it was being taken out of the stream, what would happen is if you're not up on the bank, typically what will happen is you get a flash flood air scenario or a higher flow event, and you don't have it up high enough on each bank, or the water flows just rapidly rise so much that it starts to wash around the outside. So the one thing that you can do is you don't want to anchor it across those D-rings on the stream bottom, because what will happen is it'll actually create tension on the fabric, and potentially cause it to rip. But you can attach the D-rings on the stream bank. So yes, what you can do is if you put it in the first 1 or 2 D-rings that go up on one side of the stream bank, in the event that you're not there to monitor it, let's say you put it in, leave it in overnight. I don't know what scenario that may be, but if you are, in the event that it does have some sort of high flow event and washes it out, it will just swing to that stream bank, and those D-rings will be able to hold it in place. I don't know if I'd recommend, I guess you could technically tie it to a tree. So hook a carabiner, tie a rope to the D-rings on one side. But I definitely wouldn't suggest doing it on both sides, because again, that'll create the tension and actually not allow it to, or cause it to potentially rip. So.
Troy, do you want to let Ty say a couple of things there?
Oh, I don't want to say no. That'd be kind of rude, wouldn't it?
You did ask me to say something. Howdy guys. Yeah, hey, Ty Farrell with Plains. We've been using this product here for a few years now, purchasing this and the HARBO boom. He did show in this presentation about using in conjunction with each other. The big advantage that we are finding is we have minimum manpower, remote areas, pipeline all over the U.S. and Canada. So utilizing these for that initial hit, for that initial response for 1 or 2 or 3 people, it gives us a really big advantage. It's where we can stop it early, hopefully, and where we can mitigate the effects on the environment, going up the banks, etc. So for us, it's been a big, huge hit and a great advantage. And maximizing, I look for small unit tactics and that what's the maximum we can do with the least amount of people. The cost savings has been very good, as shown in this presentation. Use it the first time, it definitely pays for itself. But the two in conjunction with each other, you got to play with it, you got to train with them. A lot of the questions I've been seeing, we hit on our trainings, had them happen. It's playing with it, and it does a fantastic job that I've seen in our training. And I mean, we're our remote locations we have with our facility response plans and things like that to meet that 1 hour deployment for EPA or Coast Guard. This hits what we need, and then based on the situation, then we'll bring in the trailer with all the boom and everything else. But the HARBO boom, 1 or 2 people can carry it, and along with that water gate, and just those two in conjunction with each other, 99% of what we have, it definitely helps. So appreciate the training, appreciate the definitely appreciate the tools. It took me a while to find them, but once I have, they've been very proactive in helping us out.
Yeah.
Thank you, Troy.
Yeah, thanks, Ty. I appreciate that.
Troy, I got looks like 2 quick ones here if we want to take them.
Yeah, let's keep going.
Says, what's the name of the overflow attachment for the dam? I think they're talking about the cofferdam overflow.
Yeah, so we call that the diverter attachment. Standard, I didn't hit on the specs on that, but again, I know I said 1,440 gallons a minute through it. Also comes with 75-foot flexible hose. So you get the hard plastic diverter attachment and 75-foot of flexible hose that easily attaches to that. If you need longer than 75 feet of hose for whatever reason, the end of that hose actually has heavy duty Velcro, just like the water gate itself. So you can attach multiple flexible hoses to run whatever lengths you need to.
And what is the expected shelf life between deployments?
Unlimited shelf life. I mean, as long as you properly care for them by just, power washing, hosing off after the fact, and then allowing them to dry. And then rolling them back up after they've dried, you're going to get, obviously I can't say hundreds of years because it hasn't been around that long, but, I'm confident in saying at least 20 years as long as you properly care for them.
And that's all the questions.
Did you say Rex had a hand raise?
No, he was trying to do the thumbs up for that first slide in the beginning.
Gotcha. All right, perfect. All right, well, I guess, Bill, did you have anything else you wanted to add?
I do not. Good input from the attendees. I'll just reiterate that everything that you saw today is how the thing actually works. It works brilliantly. Several of us have been on here today and been advocates for it, and I would not speak up if I didn't trust this product and use it myself. So.
All right, Mike, want to take her away?
Perfect. Yeah, Troy, Bill, thank you very much. Very valuable information today, and thank you for everybody that contributed, asked questions. Ty, thanks for your comments as well, and Sarah, obviously, for managing the chat. We're keep an eye out because again, the tools that our training and marketing teams have put together to add on to the layers that Bill and Troy added today with implementation and care for the underflow cofferdams. Those tools are going to be in a link that you'll get in via email literally within a few hours. So keep an eye out for that. And then also we are gearing up for our next part in March, the second week of March for our webinar series to continue for 2022. So excited to be with everybody today. Thanks for everybody's involvement. And as always, we're here for you. Our contact information is on the slides as well that you saw today. Happy to work with you and excited for the next time we get together. Thanks again, guys.